कंपैरिजन टेस्ट, नाम से ही पता चल रहा है कि किसी चीज़ को कंपेयर करा जा रहा है। मतलब कोई दो सब्सटेंस को जब हम तोलते हैं ऑन विच ग्राउंड, ऑन विच बेसिस, वेदर इट इज़ मोर फैट, whether it is more thin, whether it is more in mass. So we compare any two substance or more than two in the ground on the basis of some color, some mass, some quantity. Similarly, comparison test gives you the knowledge whether to check, to verify that your series is convergent or divergent. How? Let's look into this. If series un and series vn be two given series such that un upon vn is a finite, means dividing un and vn, if you get a finite quantity and non-zero, then you can say that your series un and vn are either both convergent or both divergent. What does the statement means? Why both? Because comparison test will give you a knowledge, a basic idea of the quantity, either it is convergent or divergent. मतलब आपको un vn को डिवाइड करना पड़ेगा. लेट्स से k कोई फाइनाइट क्वांटिटी, कोई नंबर है. अगर फिर आप un को un प्लस u2 u3 टिल इन्फिनिटी, सिमिलरली vn को भी आप उस तरह से तोड़ सकते हैं. इफ़ RHS series, that is series vn, will be convergent if its sum must be finite. ये कन्वर्जेंट कब होगा? हमें पता है कन्वर्जेंट तब होगा जब ये फाइनाइट आए, ऑल्सो नॉन ज़ीरो आए. तब हम कह सकते हैं कि ये इस साइड का टर्म हमारा कन्वर्जेंट होगा. लेट दिस बी इक्वेशन नंबर 1. So from equation number 1 we get this on LHS and K product K1, where K1 is nothing but the sum of Vn, which is actually a finite quantity. So ये हमारा RHS side हो गया completely finite. This means LHS side is equal to a finite quantity. This means series UN will also be convergent. So again, if RHS Vn, series Vn will be divergent, then the sum must be plus minus infinity. Then from 1 we get this again. If so, this was up to this, it was the case of convergency, to prove the series is convergent. So we have proved till here. In the second case we will take RHS and we will continue to solve, and if we end up having plus minus infinity on RHS side, so we can conclude from this that our LHS, that u1 plus u2 plus u3 till infinity, is nothing but plus minus infinity. Means again, due to the divergency of RHS side, my LHS side is also becomes divergent. So series u1 will be divergent. Hence, if series un and vn are two series of positive terms such that un upon vn is finite, when n tends to infinity other than 0, then either both convergent or both divergent. Is it clear to everyone? अगर convergent होगा तो दोनों convergent होगा, divergent होगा तो दोनों divergent होगा. इन दिस कंपैरिजन टेस्ट हम सिंगुलर का नहीं निकाल सकते. सिंगल अगर ऐसा भी आप बोलोगे, ऐसा भी तो हो सकता है कि सिर्फ un हमारा कन्वर्जेंट हो, vn डाइवर्जेंट है, बिल्कुल हो सकता है. बट उसे हम कंपैरिजन टेस्ट से फाइंड आउट नहीं कर सकते. उसे हम आगे नेक्स्ट जो टेस्ट है वो उससे फाइंड आउट होगा. तो हम इसमें इसका ड्रॉबैक कह सकते हो, द लिमिटेशन ये है कि दिस टेस्ट ओनली टेल्स यू द कन्वर्जेंसी एंड डाइवर्जेंसी अबाउट बोथ द सीरीज. it can't able to find the convergence and divergence of a single or particular series. So this is its drawback. So for this we have another series, that is auxiliary series or p हार्मोनिक series. कई लोग इस टेस्ट को p टेस्ट के नाम से जानते हैं, p टेस्ट. ठीक है, सो कुछ भी कीजिए चीज़ एक ही है. What is its statement? Let's look into this. If un, series un is 1 upon n to the power p, means this can be expanded in this form, 1 upon 1 to the power p plus 1 upon 2 to the power p, 3 to the power p, and so on and so forth. So this will be convergent if p is greater than 1, and if it is divergent if p is less than equal to 1. This means if my value p is more than 1, then my series is convergent, and if it is less than as well as equal to 1, then it is divergent. So this is the statement. So we will first look at the case 1, when p is greater than 1. Let's look into the proof. This is case 1, when p is greater than 1, series un is equal to this. Okay, now here this is very important for the understanding. Why? Because इसमें एक न्यू मेथडोलॉजी का इम्प्लीकेशन करेंगे. सपोज 2 का पावर n, ये यहाँ क्यों इम्पॉर्टेंट है? बिकॉज वी विल ग्रुप अकॉर्डिंगली 2 का पावर n. आप 1 अपॉन 1 का पावर p को रिमेन साइड अनटच्ड रखिए, देन वी विल ग्रुप अकॉर्डिंग एज 2 का पावर 1 2, तो हमें नेक्स्ट दो टर्म को ग्रुप करना है. फिर 2 का पावर 2 दैट इज़ 4, फिर नेक्स्ट 4 टर्म्स को हमें ग्रुप करना है. फिर 2 का पावर 3 दैट इज़ 8, नेक्स्ट 8 टर्म्स, सो ऑन एंड सो फोर्थ likewise. Now here we will use the concept of approximation. Now if you guys don't know what is approximation, let me tell you, किसी भी चीज़ को approximate value लेके दिखाना, whether it is greater than that quantity or it is less than, means कोई एक approx value लेना. Here in this case हमारा 1 upon 2 का power p है plus 1 upon 3 का power p है. We know that 1 upon 2 is greater than 1 upon 3. Is everybody agreeing with me or not? We know that 2 is less than 3, but 1 upon 2 is greater than 1 upon 3. So we will use 1 upon 2 to the power p plus 1 upon 2 to the power p. Again in this group we have 1 upon 4, 1 upon 5, 1 upon 6, 7. So the terms are going decreasing and decreasing as we are heading towards right side. So we will use the approximation method, and in this case we know that 1 upon 4 has the highest value. So we will write 1 upon 4 to the power p, 1 upon 4 to the power p in each and every case. Then similarly when we group the next 8 terms, we have 1 upon 8 the highest number, so we will use that in 8 different times. Okay, so when we use the process of approximation, our equal to signs get changed to greater than signs. This is inequality, this is the inequality, so we will have this inequality which is greater than, okay, which is in, now you can here find that 1, this is how many times? This is 2 times, so 2 upon 2p. If you take the LCM of all these, you will get 4 upon 4 to the power p, 8 upon 8 to the power p. And if you are clever enough to see that this is a series in GP, then you are genius. It is a series of GP whose nth term is 1 upon, whose common ratio is 1 upon 2 to the power p. So which is in GP, whose common ratio is this, and we know that 1 upon 2 to the power p is less than 1. Less than 1 means 1 upon 2 is less than 1. So 1 upon 2 to the power p is also less than 1. क्योंकि आप p का वैल्यू कितना भी लो कितना भी लो कितना भी लो, वो 1 से हमेशा छोटा ही रहेगा. So by geometric series, RHS of 1 will be convergent. So LHS series less than a convergent series also be a convergent. So here in this case, we have noticed that this is less than 1. Okay, so we were solving for p is greater than 1. So if p is greater than 1, if we put 2, 4, 3, 8, 7 more than one number, we are having convergency. So geometric series RHS 1 will be convergent. So if RHS is convergent, then LHS will also be convergent. We have seen the comparison test. So we will use the comparison test here also. In case 2, so is this clear? Case 1, this is a new step, new method of approximation. Those who are new to this will face some kind of difficulty. Then case 2, when p is equal to 1. So when p is equal to 1, here 1 upon n, 1, 1 upon 2, 1 upon 3 till 1 till infinity. Similarly, we will group it accordingly 2 to the power n. So in the same manner, 1 by 2, 1 by 3, 1 by 4. So p is missing in this case because we have assumed that p is equal to 1. Okay, for case 2. Now we are end up having n by 2. You can see simply the approximation part, 1 upon 4, 2 upon 4, that is 1 by 2. This is again 4 upon 8, that is 1 by 2. So and 1 by 2, 1 by 2, 1 by 2. Sum of all the 1 by 2, you will have n upon 2 because we are just ignoring 1. The first term is being ignored. Okay, so n upon 2. If n tends to infinity, we are having infinity. Infinity upon 2 is nothing but infinity. So in the RHS part, we are getting infinity, which is divergent. So RHS of 2 will be divergent. Thus LHS of 2 greater than a divergent series also must be a divergent. RHS divergent hai, to LHS will also be a divergent. Similarly, when p is less than 1, here we have n to the power p is less than n for all n where p is less than 1. So n to the power p is less than n, but when we reciprocate this, 1 by n to the power is greater than 1 upon n. This is simply just the reciprocal system. 2 3 से छोटा होता है, बट जब आप 1 by 2 उसको रेसिप्रोकल कर दोगे तो वो 1 by 2 1 by 3 से बड़ा हो जाता है. सिंपल और कुछ नहीं, बस 1 by 2 और 3 का कंसेप्ट रखो. ठीक है. देन हियर फॉर ऑल n हमारा 1 by n to the power p is greater than 1 by n. Now taking the series on both the side, what do you have? We have, in the above cases, we have seen that 1 upon n is divergent. So 1 upon n, if it is divergent, so this will also a divergent quantity. So hence un is equal to 1 upon n to the power p will be divergent if p is greater than 1. And sorry, here a bit correction needed. So 1 upon n to the power p will be convergent if p is greater than 1 and divergent if p is less than or equal to 1. So this is just simple. Let's recap again what we learned today. The statement of comparison test is if series un and series vn will be a two given series such that when n tends to infinity, un upon vn gives a finite and non-zero quantity, then we can assume that my series un and vn both are convergent, and if it gives infinite quantity, then we can assume that my series are divergent. Both the series are divergent. Then we will apply the auxiliary test or P harmonic test or P test. So here its statement says that if the series is in the form of 1 upon n to the power p, and if p is greater than 1, then it is convergent, and if p is less than or equal to 1, then it is divergent. In the next video we will proceed with the questions. We will do a lot of questions which have already asked in previous year questions of many competitive exams, college exams, which are the most important question. Don't miss that video because that is very important. So for more updates, subscribe to my channel, hit the bell icon for every videos. Okay, thank you.